Let's jump right into this explainer of Aaron Klabau's truly fascinating book, Second Nature. Now, if you're watching this, you're probably already thinking pretty deeply about how to best support the next generation. But, this book takes a completely different angle. It reveals how we can use practical neuroscience to raise highly capable kids. Because it turns out, parenting isn't just about modeling good behavior. It's actually about actively shaping the physical architecture of a child's brain.
We live in a world absolutely dominated by computers, right? We can Google any fact. Voice recognition software is making spelling drills totally obsolete. And we're even seeing advanced algorithms draft entire reports. So, how do you future-proof a child when AI can basically write their term papers? It's a huge, vital question for parents and educators. We really have to figure out what skills our kids actually need to thrive in a future where they'll be competing alongside artificial intelligence.
And that brings us to a really fascinating contrast. On one hand, we have this strict, rule-based memorization we so often teach kids. On the other hand, we have the uniquely human skills they actually need to avoid being replaced by tech. Think about it. Computers require just two things to work perfectly: incoming information and strict rules to execute it. They are unbeatable at speed and facts. But us humans? We are fundamentally better at finding solutions to messy, rule-bending situations. We adapt when the rules fail. So it kind of makes you wonder, why are our schools and homes so often focused on cultivating computer-like traits in kids, like rapid fact memorization, instead of focusing on what makes us uniquely human? To break this all down, here's our roadmap for today's explainer. First, parenting for the future. Second, the neuroscience of practice. Third, 3 essential human skills. Fourth, the ultimate goal, which is self-regulation. And finally, shaping future free will.
Let's start with Section 1, Parenting for the Future. So here's a concept that absolutely shifts how we view raising kids. Experience is a drug. We have to completely rethink our priorities here. Instead of pushing those computer-like traits, we need to focus on experiences that actively shape our children's neural architecture. It's literally biology in action. Through the mechanisms of epigenetics and neural connectivity, the specific, tangible daily experiences you put in the direct path of a child actually turn genes on or off. And that permanently alters how their neurons communicate with one another.
Moving on to Section 2, the neuroscience of practice.
This brings us to the biological reality of use it or lose it. A child's brain literally rewires itself based on the habits and behaviors they practice every single day. This is what we call neuroplasticity. Get this. At about 8 or 9 months of age, a baby has the absolute maximum number of synapses. Those are the connections between neurons. But after that peak, the brain starts this massive pruning process. It aggressively eliminates the neural connections that go unused and strengthens the ones that get activated. So if a child practices sharing, that specific pathway strengthens. But if they practice conflict avoidance, well, that pathway strengthens instead.
And the brain doesn't just keep the useful connections. It physically upgrades them through a process called myelination. Think of learning a physical sport, like tennis. Practicing complex emotional behaviors physically thickens the myelin, which is basically a fatty insulation, around brain pathways. Studies actually show that when people practice playing the piano, the white matter in their brains physically changes. And the exact same biological process happens for practicing emotional regulation. The pathway gets more myelin, making those specific behaviors faster, easier, and quite literally, second nature.
All right, Section 3, 3 essential human skills. Now, looking at these 3 essential skills, creativity, empathy, and self-control, what's super interesting is that they aren't just isolated talents. They deeply feed into one another on a neuroscientific level. If you cultivate any one of these skills, you are inherently bolstering the other 2, simply because they share underlying neural real estate in the developing brain. Let's start with creativity. It's not just about art. It involves bending the rules to solve messy problems and bridging Western concepts of innovation with Eastern concepts of self-expression. The author mentions this really fascinating study of 126 undergrads who were asked to draw a neuron. Most of them just reproduced a boring, standard textbook image. But when the students were first asked to act like a neuron, literally fanning out their arms wildly to mimic cellular growth, their drawings became vastly more creative and varied. Teaching creativity makes variation okay, and that is something a computer program simply cannot compute.
Next up, we have empathy. This gives kids a literal superpower to predict social outcomes. When we break empathy down into 3 types, emotional, cognitive, and applied, it becomes clear that applied empathy is what truly changes the world.
I mean, a computer can be programmed with cognitive empathy to offer you an automated discount code when you complain to customer service. But applied empathy requires genuine action. For example, if a child sees a friend drop their ice cream, cognitive empathy is understanding they're sad. Emotional empathy is actually feeling sad with them, but applied empathy, true compassion, is having the imagination and social collaboration to offer to share their own ice cream.
The third skill is self-control. This is that moment of friction between what a kid wants to do and what is actually in their best interest. We often praise kids for self-control, right? But think about it for a second. Sitting on your hands so you don't hit your sibling is really just a state of inaction. There's no intrinsic, personal reward for just doing nothing. So while stopping a bad behavior is absolutely crucial, it's really only a stepping stone to something much, much bigger.
Which brings us to Section 4, the ultimate goal, self-regulation. Self-regulation is an ongoing, continuous loop, a spiral of forethought, action, and reflection. If self-control is just biting your tongue, self-regulation is saying, okay, I can't take this toy right now, so let me figure out another way to get what I want without hurting anyone. It's the whole package. It combines the creativity to think of a new solution, the empathy to care about the other person's feelings, and the self-control to pause that initial impulse. It's what allows a child to pivot their behavior constructively toward a goal.
So how do we foster this? To build these complex self-regulation circuits, parents have to scaffold experiences by actually stepping back. The science highlights the absolute necessity of unstructured free play. Ever wonder how 3M invented the Post-it note? They literally gave their adult employees 15% of their time as unstructured free play to simply chase ideas. Without adults directing the rules, kids are forced to practice conflict resolution, rulemaking, and adapting. If highly trained adult engineers need that space to innovate, our children desperately need it to wire their developing brains for resilience.
Finally, Section 5, shaping future free will.
The philosopher René Descartes used to argue that the human mind was freely given and totally separate from the physical body, but modern neuroscience completely shatters that idea. The author highlights that a child's future freedom to choose is actually biologically limited or expanded by the physical neural pathways their early environment reinforces. If you constantly solve a child's problems for them, the neural pathways for independent problem solving get pruned away, permanently. So in a very real sense, their future free will relies directly on the biological hardware you help them build today. Every single interaction, every unstructured play session, every boundary you set is leaving a physical epigenetic mark on your child's brain. Since you have the power to sculpt your child's biological hardware, I want to leave you with this provocative thought. What habits are you helping them make second nature right now? Thanks so much for joining me on this explainer of second nature.